So it's the same thing with food. We need food to live, gives us energy, but at the same time it produces some toxins. There's some toxins in these cells. But our bodies are very smart, our cells are very smart, and they deal with these toxins. They repair any damage that happens before it gets too bad. But if it gets a little bit too much, and if it happens to happen in your knee, well, you'll get arthritis. If you get it in your heart, you get heart disease. You get it in your brain, you'll get some sort of brain disease. So that's one effect of food. The other effect of food is that the cells get bigger. So they get bigger and they grow and then they divide. And then you remember some of you from first year high school biology, right? The nucleus grows and it splits in two and it duplicates. But every time you do things like this with genes and with chromosomes, every once in a while something goes wrong. The body fixes it up to a certain point. After a certain point, you end up with a mutation, and then something else will happen. Some sort of disease process will happen. So the bad news is you have to eat less. You have to eat less. A very interesting study that was done, it's still ongoing actually, it's called the Wisconsin National Primate Research Center. It's an ongoing study. These two monkeys, which one do you think is the older one? They're the same age. The one on the right eats too much, and the one on the left is given a little bit less. Look how the one on the right looks. It's about hair day. It looks kind of grumpy, and it looks a little bit hunched over. The posture is bad. They're the same age. Not only does the one on the right look older, but the ones on the right have more disease. The ones on the left have less disease. What does this have anything to do with you and me? Sort of the story, a guy comes home and says, hey, did you hear scientists say that we're descended from chimps? Said, maybe your side of the family, not my side of the family. But genetically speaking, really, there's very, very little difference, never mind with chimpanzees, even with the worms. We share a very, very large common genetic pool. So these are ongoing studies. Again, humans are much more complex than chimps. But some people, there's a group of people called the Calorie Restriction Society. And the founder is a gentleman called Dr. Roy Walford. You may remember them. They moved with a group of people. They went to go live in a bubble, right? And they went to go live in Arizona. And these are people who measure exactly down to a gram what they eat, how much broccoli they eat, how much potato they eat, down to a gram. They take things to quite an extreme. And they are convinced that they are going to be living longer and better, remains to be seen. And meanwhile, poor Dr. Wolford, soon after getting into the bubble, he developed Lou Gehrig's disease and passed away. So, but it's called the Caloric Restriction Society. And you can look them up on the internet. They've been on 2020. You've seen little clips. They look miserable. I have to tell you, they look really miserable. Red wine, right? Resveratrol, red wine. The red wine. Who's heard about red wine? Drink red wine, you'll live forever. I don't think they meant Manischewitz, but. What they're thinking of, again, studies have been done, again, on worms, yeast, fruit flies, and even this Dr. Kenyon, the one who was studying the worms, is looking now at the resveratrol. So it seems to prolong life in these species of animals. And so what is thought, again, I don't want to get into all these details, into the deep genetics of it, but between the red wine and the DAF32 hormone, it pushes things more into cell repair and maintenance. To prevent the degeneration of the cells, which will eventually lead to degeneration of tissues, which will lead to disease. And a lot of these people who are involved in this kind of study, they've gone actually into private industry. They founded their own pharmaceutical company. It's called Elixir. And they've got tremendous amounts of capital and resource that they're investing into this. So it remains to be seen. Tricky thing with all this kind of stuff is that again, once you take resveratrol out of red wine, it becomes a whole other story. maybe in its natural components it works, but when you start to isolate compounds out from their natural source, it's not quite the same. So again, metabolism causes damage, and damage will eventually cause trouble. What we're looking for is where this aging switch is that we can manipulate with either genetic or dietary or environmental interventions. Now, the National Institute of Health in the United States, their budget is about $25 billion, but their budget on aging is not even 0.1%. So again, if you think all diseases really probably have a common sort of source, that's really where the money should go. Not until all these separate sort of categories: heart disease, arthritis, brain. It's all got a common kind of source. Okay, so let's divert a little bit. Let's go through some questions. Retirement is bad. People become ill and die after they retire. Is that true or false? True, false. How many say true? How many say false? False, completely false. Yes. No, retirement. When you start to ask people more questions, you find out they had very good reasons to retire already. They weren't feeling well, this, that, a whole bunch of other sort of things. True or false? Somebody over the age of 65 rarely produces something productive. A hard sciences scholarship. False. Hey, there's many examples. I showed you many people in the slides, who are tremendously productive, well past 65. True or false? False. Okay. The format may change, but we remain sexual beings all our life. Remember, I have a patient who I had for years would come and see me with all sorts of things. This hurts, that hurts, all bunch of kind of stuff, and came again with the usual kind of things. And I said, it's fine. I said, no, look, very good. So we started to talk a little bit more. She started talking about her late husband, who I knew very well, who passed away very tragically, very unexpectedly. And so we just keep on talking, and Dr. Friedman has to go. And she said, and I have a boyfriend. Okay, boyfriend, I'm happy, you're happy, we're all happy, that's very good. And she keeps on talking, and she says, with my late husband, it wasn't so good the last few years. He was sick, and he wasn't the same person. I said, yeah, he was a very fine man, I enjoyed him too. Dr. Friedman has to go, And she says, no, you don't understand. Okay, I don't understand. What don't I understand? I have a boyfriend. Okay, he wants to. So I said, Dr. Friedman really has to go now. They didn't teach me these things in school. Anyways, I couldn't get out of there, and we had to talk a little bit. And the last thing she told me, she said, thank you very much, but one thing, please don't tell the children anything about me. It's impossible for older people to learn something new. False. Okay. More than 80% are healthy enough to, well, I already showed you these statistics, so this is, it's true, right? Most people, older people, are healthy, right? Health Canada survey. Everybody's heard of osteoporosis, right? Osteoporosis, so it's a thinning of the bones, a weakening of the bones. If you get it in the spine, it affects your posture, right? You end up being a bit hunched over. If you get it in your hip can break and you can fall down. How many of you have heard of sarcopenia? Sarcopenia is actually an emerging area of study. I predict it's going to become as important an issue as osteoporosis. Sarcopenia means poverty of flesh. And it's the losing of muscle mass. So you see on sort of the left, big bulky bicep muscles, big bulky arms. And then later, as you get older, you lose the muscle mass and your stomach gets bigger. And this gentleman on the right is trying to counteract that. So sarcopenia, again, we're just starting to sort of look into this area. It's been measured for many, many decades already that there is a loss of at least 1% per year of muscle mass past the age of your mid-20s, and associated corresponding loss of muscle strength.